Hey there, and welcome to The Explainer. Today, we're kicking off a bit of a cosmic investigation. And our main subject, well, it's this gorgeous blue marble we all call home. We're going to dig into the evidence, you and me, to really figure out what makes our planet not just some random rock, but a perfect, thriving haven for life in the middle of, well, everywhere else.
And let's start with a core idea for our journey today. Your potential is limitless with the right mentor. Welcome to the Don Raj Sir method. That's what we're doing here. We're going to try to really live the subject of planet Earth.
So that brings us to our big question, our central mystery. Look, we know Earth is a planet, right? A big round thing that goes around the sun. But when you think about the sheer number of rocks out there in the cosmos, you have to wonder, what is it about this one? What makes it so special that it can support something as wild and complex and beautiful as life itself?
Okay, so here's our game plan. First up, we're going to properly identify our subject and its real shape. Then we'll look at what makes its conditions so just right. After that, we'll dive into its amazing recycling systems, double-check the evidence for its shape, and finally, we'll deliver the verdict on that tiny, thin layer where all of life actually happens. All right, let's get started. First stop on our investigation, let's properly identify our subject. We'll start with its true shape, which, believe it or not, is basically a squashed sphere. Now, you probably grew up thinking Earth is a perfect ball, but the technical term is an oblate spheroid. It's a fancy way of saying our planet is a sphere that's just a little bit flattened at the top and bottom, the poles, and kind of bulges out a little around its belts, the equator. And the proof is right here in the numbers. You can see it for yourself. If you measure the Earth from side to side at the equator, it's about 12,756 kilometers across. But if you measure it from the North Pole straight down to the South Pole, it's just a little bit shorter, 12,714 kilometers. And that difference, just 42 kilometers, might not sound like much, but it's everything. It's the key piece of evidence. See, as our planet spins and spins, that motion, that centrifugal force, pushes everything outwards at the equator. It's what creates that bulge and gives our planet its very unique shape. So, now that we know its shape, let's move on to the really juicy stuff. We're on to our second piece of the puzzle, Earth's just right conditions. You can think of this as the Goldilocks evidence. Let's just think about the air we're all breathing right now. Our atmosphere is not some random jumble of gases. Oh no, it is a very precise, very specific recipe for life. It's about 78% nitrogen, a totally critical 21% oxygen for us to breathe, and then a mix of other gases making up that last 1%. That exact balance? That's what makes it all work. And it's not just the air, it's the temperature. I mean, just look at our next door neighbors. Venus is a blistering 462 degrees Celsius. You'd be toast. Mars is a deep freeze at minus 63. And Earth, we're hanging out at a comfy average of 17 degrees. See? Not too hot, not too cold. It's just right. And that's all because we're at the perfect distance from the sun. So what's the secret ingredient that keeps everything so stable? It's water. Simple, amazing water. It covers 70% of our planet's surface. That's why we call it the blue planet. But it's not just for show. Water is a master climate regulator. It soaks up a ton of heat when it's sunny and then slowly releases it at night. This prevents those wild temperature swings that would make life pretty much impossible.
This brings us right to the heart of what makes our planet tick, its living engine, nature's incredible recycling systems. This, my friends, is where things get really, really cool. Take the hydrological cycle, the water cycle. It's this beautiful, never-ending loop. Water evaporates from oceans and lakes, it rises up, forms clouds, and then falls back down as rain or snow. This system is like a planet-wide delivery service, making sure our most precious resource gets distributed to every corner of the globe over and over again. And then you've got the nutrition cycle, which is all about how energy moves around. It's a wonderfully simple three-step process. Step 1, you've got producers, like plants, making their own food from sunlight. Step 2, you've got consumers, like us and other animals, getting energy by eating those plants or each other. And then the final crucial step. Decomposers break down all the dead stuff and return those nutrients right back to the soil. The engine that powers that whole cycle? The food chain. You can see it right here. It shows exactly how that energy flows from the sun, gets captured by a producer, the plant, and then moves all the way up through the consumers.
It's the perfect picture of how every single living thing is connected in this amazing self-sustaining system.
Okay, we've laid out the shape and the life support systems. So now let's do a quick, rapid-fire rundown of the evidence. We're going to prove our planet's shape by corroborating the facts we already know.
You know, we didn't figure this out overnight. It's been pieced together for centuries. It started back in ancient Greece, when sailors noticed a ship's mast was the first thing you'd see coming over the horizon. Then, in 1522, Magellan's cruise sailed all the way around the globe. In 1838, the Bedford-Level experiment physically proved the Earth's curve. And of course, in the 20th century, we got the ultimate proof: pictures from space. And here is a fantastic piece of proof you can see for yourself any day. Because the Earth is a spinning sphere, we have sunrise and sunset. The sun appears at different times in different places. Now, think about it. If the Earth were flat, like you see on the right, sunrise would happen for absolutely everyone everywhere at the exact same time. The very fact that it doesn't is proof of our round, rotating world. So, where does all this evidence lead us? Let's bring it all together for our final verdict. And it all comes down to this one idea: the thin layer of life. And that layer is called the biosphere. It's not a single place, but it's this incredibly narrow zone where everything we've talked about comes together. It's that precious, magical intersection of the atmosphere, the air, the lithosphere, the land, and the hydrosphere, the water. This overlap is the only place in the universe we know of where all the conditions are just right for life to exist. And here's the part that just blows my mind. It's how incredibly thin this layer is. I mean, from the bottom of the deepest ocean trench to the top of the highest mountain, the entire zone that supports every single living thing we've ever known is only about 15 kilometers thick. It's like a fragile, delicate film on the surface of a giant rock. So here's the final takeaway. All of those perfect Goldilocks conditions, all those intricate recycling systems, the entire story of life as we know it, it's all happening inside this one fragile life zone. This is it. It's all we've got. Which leaves us with the most important question of all: how do we protect it?